Now, just to let you know before I start the videos, these questions from HSC, okay, from various years. Okay, now, question number 1. The table shows the relative frequency of selecting each of the different color jelly beans from package containing green, yellow, black, red, and white jelly beans. So green is 0.32, yellow is 0.13, and black and 0.14. Red we need to find out, and white, okay, is 0.24. These are relative frequency. Okay, in theory we call probability because this is experiment. Okay, in practice, so we call relative frequency. Okay, so if you don't know what is relative frequency and how it works, please watch my previous video and you'll find out, okay, a bit more about that. At the moment, these are applications, so I'll just go straight into it. Okay, now if you look at the table, the relative frequency here, okay, it must add up to one whole. Okay, this one add up must give me one whole, so keep that in mind for me. Okay, so at the moment, if you go 0.32, okay, add 0.13, add 0.14, and add whatever that is red, and then add 0.2 should give me one whole. I'll repeat that. Okay, now what is the relative frequency of selecting a red jelly bean? So a red, see red here, so you need to find out what this blank is. So therefore, to find out the relative frequency for red, so you go 1 minus 0.32 minus 0.13 minus 0.24, which is equal to 0.17. Okay, so that is the relative frequency for a red jelly bean. Now alternately, you can just add these up and add these up, and then 1 minus that. It's the same thing. Okay, now let's move on second part. Based on this table of relative frequencies, what is the probability of not selecting a black jelly bean? So a black jelly bean, I just need to move this up a bit first, so you got more space. So if you think about a black jelly bean, the relative of it is 0.14. Okay, I just leave up to here. So therefore, okay, not black, so which is 1 minus 0.14. Okay, so 0.14 is 0.86. That's it. Okay, so that's what it is. Okay, next questions. Okay, in an experiment, a standard 6-sided die was rolled 72 times. The results are shown in a table. So this is the score, number of die, 1 to 6, and frequency means the outcome. Okay, so 1 come out 6 times, 2 come out 12 times, 3 come out 10, 4 come out 20 times, 5 come out 9 times, and 6 come out 15 times. Okay, which number on the die was obtained the expected number of times? So when you read the questions, it's quite confused, right? They said which number on the die was obtained the expected number of times. So what that means is which one of these are come out as same as in theory. Okay, so in theory, because you rolled 72 times, correct? It said that 72 times. So in theory, the probability of each of them is 1/6. Okay, in theory. So therefore, 1/6 times 72. Okay, which is what? 12, right? So in theory, each of those should come out like 12, 12, 12, 12, 12, 12. Okay, that's what that meant. All right. So in theory. So the question asked is this. I just move it up here so you can see. See, it says which number on the die was obtained the expected number of times. So which one is that? So this is one come out same with in theory. So it's in practice it come out as 6. In theory 12. See, the score 2 is 12 come out 12 times. See, it's the same as with theory. Okay, so in theory it's 12. In practice it's also come out 12 times. So the rest are not. Okay, so which is the answer is B, which is 2 times. Okay, so that's what it is. Okay, so it's come out 1 come out how many times? 6 times. 2 come out 12 times. So same with the theoretical probability, right? In theory come out 12 times, and in practice it's also come out 12 times. It just happened to be. Okay, so 3 come out 12 times in theory, but in practice only 20 times. 4 out 10 times. 4 it come out 20 times, and then 5 come out 9 times. So they're all different from theory. Okay, so which is 2 is the only one the same. So that's the answer. A spinner with different color sector is spun 40 times. The results are recorded in the table. So if you look at this, okay, red come out twice, yellow come out 4 times, blue come out 6 times, orange not sure, green 10 times, and purple 12 times. Now the question is this: what is the relative frequency of obtaining the color orange? So the answer is, you got choice, multiple choice. You got 3 out of 20, 1/5, 6, or 8. So obviously, okay, you can see that clearly this one are wrong anyway, because relative frequency is just like probability. Okay, but in practice we call relative frequency, so it cannot be more than 1. Remember that for me. Okay, so obviously both are wrong. Anyway, look back. I'm gonna move back to the question so we can go through it. Okay, so by looking at this, okay, there are 2 ways to do it. One way, okay, I'm gonna do 2 ways. Let's do this way first. So you want to find out orange first. To work this out, okay, 6 plus 10, 6 plus 4 is 10, add 2, this is 12. Okay, so this is 12, and this is 22. So you add them up, give me 33. Happy with that? So therefore, okay, the probability not orange, okay, is what? Is 33 out of, 34. Sorry. So there is 2 ways to approach this problem. Okay, just leave it like this first. So the first way, okay, it will just add this up first. 4 plus 6 is 10, plus 2 is 12. These add together give me 22. So if you add 12 plus 22, okay, that is 34. So that is not orange. Okay, 34 of them are not orange. So this means that, okay, 40 altogether. So 40 minus 34, 40 minus 34 is what? Is 6, right? So 6 left. So therefore the probability, okay, of orange is 6 out of 40. You see? So if you have that, give me 3 out of 20. So that should be your answer. Okay, so the relative frequency of obtaining the color orange is 3 out of 20. That is your answer. Or I can do this, okay, or I can do the probability of not orange, okay, is 34 out of 40. Now if we simplify this, give me 17, half 34 is 17 out of 20. So therefore, opposite of that, the probability of not orange is 1 minus that. So 1 minus 17 out of 20. So it's the same as 20 minus 17. So 3 out of 20. Okay. So your answer is A. Correct? So that's your answer. So it should be A. A bag contains red, green, yellow, and blue balls. The table shows the probability choosing a red, green, or blue ball from the bag. If there are 12 yellow balls in the bag, how many balls are in the bag altogether. Now, before you even do anything, you need to understand that, okay, the probability, okay, which is this probability, this column here, must add up, give me one whole. Okay, the theory of probability. All together add up must give me one whole. So therefore, we can figure out what's the probability of getting a yellow. So before we do this, we just add these probability first. So 1/3, add 1/4, add 1/6. Okay, so if you put that in your calculator, and you should get 3/4. You see? So this add this is 3/4. So therefore, so you get to get yellow, okay, 1 minus, because add up give me one whole, 3/4. So your answer should be 1/4. So this is 1/4. That's all for now. Then the question says, if there are 12 yellow balls, so which mean that 1/4 is equal to 12 yellow balls. So which is like this. I just draw very basic understanding of fractions. See, like this. Okay, 2, 3. So this, each of these 1/4, so each of these is 12. See, 1/4 is 12. So each of these 12. So another 12, another 12, another 12. So the question asks how many balls are in the bag altogether. So which is 12 times 4. That's all. So just 12 times 4 equal 48. Okay, so there are 48 balls altogether. So the answer is 48. C. Okay. 2 unbiased dice with face number 1, 2, 3, 4, 5, 6 are rolled 18 times. The difference between the numbers on the uppermost face is recorded each time. John performs this experiment twice and his results are shown in the tables. So experiment 1, the difference 0, difference 1, difference 2, difference of 3 and so on. Okay, the record on here, frequency. So the difference of 0 come out 3 times, difference of 1 and 3 times. Similar with experiment 2. Okay, now the question is this. John states that the experiment 2 has given result that closer to what he expected than the results given by experiment 1. Is it correct? Explain your answer by finding the sample space for the dice difference and using theoretical probability. So when you look at this question is quite tricky, because first of all you need to understand what's happening first. Okay, by looking at the table, you already know that, when you roll 2 dice, so they come out, for example, if it's 1 and then 2, okay, the difference is 1. See, that's what that meant. And if it's 6 and 6 or 2 and 2, the difference is 0. So these are the result record. Okay, keep that in mind for me. And what happened, and he's actually did that 18 times. One of them 18 times and record experiment 1 and he finished. Then you're gonna do, he did another experiment, so record on experiment 2. So you got 2 different results here. So we need to work out, okay, which experiment is close to theoretical expectations. Okay, so we have to work out theoretical, okay, probability first. Now the way to go about this is I draw diagram. So I'm gonna write here. Okay, I might have to write a bit smaller maybe because it's a long one. So let's say I'm gonna find the outcome. So I'm gonna write 2 dice. So I'm gonna write 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. These are the outcome of 2 dice. Okay, I write on the line. Okay, on the number, not between. Okay, so keep that in mind for me. I'm gonna use this diagram to find out all the probability. So you're gonna write it down. Remember that for me, on the line. I mean on the numbers. Okay, not between. So this way is easier. Now look, first of all, I'm gonna find out what's the probability of the difference is 0 first. I do in that order. So the difference 0 is 1 1. See, a circle. 1 1, 2 2, 3 3, 4 4, 5 5, 6 6. So they all the difference is 0. So 6 out of 36. 6 out of 36. So I don't have to simplify. You can simplify because expectation. Anyway, simplify makes it easier in that case. So it's divided by 6 is 1 6. See? So the expectations, okay, I gotta squeeze in here because otherwise I'll run out of space. So expectation of this is 1 6 times 18. Okay, 1 6 times 18 because you roll 18 times. Okay, so that's what you have to do. So 1 6 times 18. So your answer is 3. So it come out 3 times. Is that okay? Now, the probability of difference two phase, uppermost phase, the difference is 1. Okay, 1 is 1 and 2. Okay, and not with any other numbers. Okay, and 2 and what? 2 and 3 or 2 and 1. Keep that in mind. The difference is 1. Okay, 2 and 1 difference is 1. 2 and 3 different also. Okay, so the pattern is this. Just go 3 and 2. See, and then 3 and 4. 4 and 3 or 4 and 5. See, it's a pattern, or just all the way diagonal down. 5 and 4 and 5 and 6. 6 and 5. That's it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 out of 36. Okay, so half that. So 5 over 18. So therefore, okay, the expectation of this is 5 over 18 times 18. Okay, so because you roll 18 times. You roll 18 times, so you times that, give me 5. So that's what the expectation is for the difference of 1. Okay, so the next one. So the probability of difference of 2 is this. Okay, I'm gonna use different color because otherwise you're confused. So 1 and 3. The difference of 2 is 1 and 3. Okay, so 1 and 3. One and 3, and then 2, because remember the difference is 2, okay, 2 and 4, okay, 3 and 1, the difference is 3, 3 and 1, and 3 and 5, 4 and 2, and 4 and 6, see, I'm done with this one, so 5 and 3, that's it, and 6 and 4, again, 1, 2, 3, 4, 5, 6, 7, 8, so 8, okay, so your answer is 8 out of 36. So it's 2 9. Okay, 2 out of 9. So the expectations, I just try here, okay, the expectation is 2 9 times 18, okay, so 2 9 times 18, so that give me 4. Okay, that's the expectations. And then the probability of the difference is 3. Okay, the difference of 3 is 1 and 4. Okay, 1 and 4. Difference is 3. Keep that in mind. 2 and 5. 3 and 6. Okay, 4 and what? Good. 4 and 1. Okay, and then 5 and 2. It's just a pattern. And 6 and 3. So 1, 2, 3, 4, 5, 6. So 6 out of 36. So which is 1 6. So the expectation of this is 1 6 times 18 because you roll 18 times. Remember that? So it's 3. Now you can see my diagram getting really messy now. Of course, if you do it yourself, you have to redraw it, okay? Because you haven't got this color. So I have multiple colors, so I can just use it, so I don't have to redraw diagram. Okay, for you, in a test, in an exam situation, you can redraw the diagram, so you can make it easier for you. Okay, so I move on. I change different color now. So the probability, we need to find the probability. Okay, the probability that is the difference is 4. Okay, almost there. Okay, so the difference of 4 is 1 and 5. Happy with that? 1 and 5, because the difference is 4. 2 and 6. 3 and what? None. Okay, 3 doesn't go with anywhere. 4 doesn't go anywhere. 5 and 1. 6 and 2. See, so only 4. So 4 out of 36, which is 19. Okay, so therefore the expectation of this is 19 times 18. Okay, so which is 2. So that's what it is. Okay, now so the last one, the probability of difference of 5. You can see I'm writing getting smaller because I run out of space. So the difference of 5, okay, is 1 and 6. Okay, I do cross 1 and 6. So 2 doesn't work, 3 doesn't work, 4 doesn't work, 5 doesn't work. Okay, 6 and 1. So 2 out of 36. So which is 1 out of 18. You have that. Okay, so the expectations of this is 1 out of 18 times 18. Okay, so which is 1. That's all. Now what we need to do, okay, we need to, sorry, it's just too much information on this page now. We just need to write out all these expectations next to the table so you can compare. At the moment you look at it, you can't even see it, right? All over the place. So for 0, okay, is 1 expectation. So 1, 5, 4, 3. Okay, see that? 1, I highlight for you. Okay, so it's like this. For 1 is 3. Too hard to highlight, I circle it. Okay, so it's for 1 is 3, 5, 4, 3. Keep that in mind. 3, 5, 4, 3. Okay, so 3, 5, 4, 3, and what? And 2, 1. Okay, and 2, 1. This is theoretical. Okay, so keep that in mind. And I just write out here. Actually, write in it. Okay, in the table so you can see this theory. Theoretical. 3, 5, 4, 3, 2, 1. See? Can you see which one closer? I write in it so you can see it. Okay, 5, 4, 3, 2, 1. Okay, so which one is right? Okay, which one is closer to the theoretical probability, which is the frequency here? 4 give me 3, 4 is 3, 5 is 4 is 5, 3 is 4, 3 is 3, 2 is 2, 1. Whereas this one, experiment 1, 3, 3, 5, 2, 3, 5, 2, 4, 3, 2. So therefore, look like experiment 2 is much closer than experiment 1. Okay, so you can say John's is correct. Okay, according to theory. Okay, theoretical probability and theoretical expectations. Okay, his experiment 2 is much closer. Okay, so therefore he is correct. Alright, thank you so much for watching my videos.